In this video, we will introduce the advantages of using threads within the Java programming language. When you work in a computer, you can do several things at once. You can hear music, watch a video, edit a document in a word processor, and read your email. This can be done because your operating system allows a concurrency of tasks. What are the advantages of using threads? Advantages of multi-threading over multitasking. Multi-threading reduces the computation time, improves performance of an application. Threads can share the same address space, so it saves memory. Context switching between threads is usually less expensive than between processes, such as in multitasking. The cost of communication between threads is relatively low. It also keeps a process responsive. Some time back ago, to print a document in Microsoft Word, the application would freeze until the print job finished. You had one fleeting opportunity to cancel before you were firmly committed to waiting before your printer slowly printed up to the last page. Microsoft and other software companies fix this behavior by running print jobs on a separate thread. Developers, when having to make a decision that a particular task could take a long time to complete, and that task should be run apart from the user interface thread, have had to implement multi-threaded applications. Not just as GUI apps or desktop applications, but network services have also needed to be multi-threaded to do heavy lifting on a secondary thread to keep the customer satisfied. Keeping a processor busy. No matter how fast your CPU is, if it is not actively processing, the CPU speed becomes irrelevant. Keeping a processor working can be a difficult task. You see, there are all kinds of things that could cause a processor to idle away time. The most prevalent and common is disk and network I/O. When a single-threaded application accesses a file, calls out to a web service, or streams from a USB webcam, your processor is just killing time. Occasionally, there isn't much you can do but wait for the I/O to complete. But there is something else you could do. You could spin up while you were waiting for the process to finish. If you're processing a series of files, you can process one file while reading the next. If you're calling multiple web services, call them in parallel. Maybe one will come back before the other. Try to think ahead. Keep multiple processors busy. If you run multiple processes, that is, multiple distinct applications or multiple instances of one application, the operating system will continue to rescue and goad those other processors into action. But if you want your specific application to wrestle maximum horsepower from the hardware it's on, you've got to give the OS scheduler multiple things to work on simultaneously. And the way you could do this is through multiple threads. Simplifying code of cooperating. If you think about it, most software bugs come from either doing sometimes something difficult or doing simple in a difficult way. Sometimes you end up writing code that trips over itself trying to advance multiple tasks at once. Just as many programming problems have both an iterative and recursive implementation, many programming problems also have both serial and concurrent variations. The version you choose depends on the nature of the specific problem. Try to write a multi-client network service with just one thread. Though possible, particularly if you're savvy with Sockets API, it isn't natural. When you refactor it into threads, the code becomes logically simpler. One thread per client, one thread to rule them all. The key in using threads to simplify your code is to try to keep your functions and methods on one train of thought. Rather than turn your code into an arithmetic problem, try to interleave multiple simple simultaneous tasks. Code each task separately. Code each line block with one in mind. Let the OS thread scheduler do the interleaving. This concludes our discussion of the advantages of using threads in Java.